The next question is, among the following methods, that is addition of electrolyte, electrophoresis, addition of protective colloid, or addition of an oppositely charged sol, the coagulation of a lyophobic sol can be carried out by. Uh, to coagulate a lyophobic sol, basically we have to remove the charge present on the dispersed phase particles. We know that the only reason why the particles of lyophobic colloidal solution are not coming together to form a precipitate is because they all carry the same charge. All would be negatively charged, or all will be positively charged. The moment you remove that charge, they will come together to form a precipitate because they are being repelled by the surrounding medium, the dispersed phase, right? So because they're also repelled by each other, so they are not coming together to form a precipitate. So the moment you remove the charge, they will come together and they will form a precipitate, and that process is known as coagulation. So if you add an electrolyte, because if you add electrolyte, it will contain both the cation and the anion. So whatever the charge on these particles is, be it positive or negative, there is going to be a counter ion for that. If the charge on the particle is positive, then the anion of the electrolyte is going to be effective ion to coagulate that. It is going to neutralize the charge of the particles, and they will come together to coagulate. If the charge on the particles is negative, then the cation is going to be effective in coagulating that colloidal solution. So yes, addition of electrolyte can bring the coagulation. Second is electrophoresis. In electrophoresis, what we do, we under the influence of external electric field, these particles will be attracted towards the opposite plate. And if they have a negative charge, they will be attracted towards the positive plate, and when they reach there, they will lose their charge, and when they lose their charge, they will get coagulated. So yes, electrophoresis can also bring about the coagulation. Addition of protective colloid. The purpose of adding protective colloid is to protect this colloidal solution from coagulating on addition of electrolyte. We know that if we add electrolyte in this will get coagulated. So before adding the electrolyte, if we add some lyophilic sol as a protective agent, it forms a layer on the surface of these lyophobic particles, so they get attracted by the dispersion medium. Then on adding small amount of the electrolyte will not cause the coagulation. So this will not cause the coagulation. It will rather do the opposite thing. It will protect it from coagulation. Fourth, addition of an oppositely charged sol, that is called as mutual coagulation. If you don't add electrolyte, but rather you add, suppose the charge on these particles is negative, you add a positive colloidal solution in this, then they will neutralize each other, and both the colloidal salts will get precipitated. So yes, this will also bring about the coagulation. So 1, 2, and 4 can be used to coagulate a lyophobic salt. So the correct option for this question would be option D.